Hello everyone. Today we are starting the section on smart contracts. In blockchain technology, a smart contract is a protocol in the form of code that describes and restricts transaction behavior, enabling automated execution of digital interactions. Reading smart contract helps us better understand their code logic and programming paradigms, laying the foundation for writing smart contracts in the future. By understanding the operational methods of smart contracts, we can grasp basic concepts and operations such as defined state variables, function calls, and conditional statements. Additionally, we can also understand the application methods and limitations of smart contracts in blockchain technology and various use cases, providing references and insights for developing more efficient, secure, and usable smart contracts. For beginners who are interested in starting their journey in the blockchain field or conducting research, it is crucial to understand and master the reading of smart contracts in the initial stage. In this lesson, our focus is primarily on conceptual explanations. We'll introduce the concepts of smart contracts, their applications, the use of smart contracts in the context of ENS, and the process of reading ENS smart contracts. Now let's dive into a detailed introduction of smart contracts. Smart contracts are computer protocols that utilize blockchain technology to automate the execution of transactions. They describe and impose transaction conditions and restrictions through programmable code, which is stored in a distributed network for users to query, verify, and execute. Smart contracts possesses the following characteristics. The first is decentralization. Smart contracts do not rely on central authorities or trusted third parties for execution and supervision. Indeed, they are executed through a distributed network of nodes. The second is automated execution. Smart contracts automatically execute based on predefined logic and conditions, ensuring fairness and accuracy. The third is immutability. Once a smart contract is executed, the related transaction records and information are permanently recorded on the blockchain, and all nodes can view and verify them to ensure integrity and authenticity. The fourth is versatility. Smart contracts can support various scenarios and applications, such as issuing digital currencies, conducting commodity trades, and naming electronic stablecoins. Last but not least, high efficiency. Smart contracts eliminate the need for manual intervention by automating the execution process, greatly improving efficiency and reducing costs. In summary, as an emerging technology, smart contracts are gradually gaining widespread applications. Their emergence will bring significant changes to various fields such as finance, supply chain, logistics, voting, online executions, etc. So let's introduce the application of smart contracts. Smart contract applications are an important application model of blockchain technology. They utilize smart contract programming languages to describe business logic and deploy them on the blockchain to achieve distributed and decentralized business process. Smart contract applications can help build various types of decentralized applications, such as digital currencies, decentralized exchanges, supply chain management systems, bill exchange platforms, etc. Smart contract applications are an emerging technology with broad application prospects. They are changing people's perception of traditional modes, business models, and service methods, and providing new ideas and possibilities for achieving social trust and decentralized governance. To transform a smart contract into a smart contract application, a series of steps need to be taken, which can be divided into several stages in sequential order: requirement analysis, code development, debug and test, deployment on the blockchain, from front-end interface development, testing and acceptance, and finally, release and maintenance. These complex processes aim to help users achieve the desired functionalities on the smart contract and enable developers to gain economic or business benefits. Today, the smart contract application we use is ENS, that is Ethereum Name Service. ENS is an open source protocol on the Ethereum network that allows users to convert regular domain names into Ethereum addresses, making it more convenient for users to navigate and use the Ethereum network. In simple terms, using ENS navigation is easier than directly inputting complex Ethereum addresses. Registering your domain name on ENS can bring many benefits to users. For example, users can use easy-to-remember names instead of long Ethereum addresses to identify their accounts and contract information. In addition, ENS supports domain name transfers, renewals, and resolution. Recently, with the growth of the decentralized finance ecosystem, the importance of ENS has been increasingly recognized. As we know, many decentralized finance protocols require the input of target contract addresses to function properly. And these addresses are often long and difficult to remember. In such cases, using ENS domain names can make these transactions simpler and more intuitive. In summary, the ENS smart contract provides Ethereum network users with a more user-friendly and accessible way, promoting the growth and development of the Ethereum ecosystem. It is important to note that when using ENS service, only writing operations on domain names trigger system calculations for gas fees. Reading ENS records does not involve state updates on the blockchain, so it can be understood as almost free of charge. Now let's take a look at the processing of reading the ENS smart contract. When developing smart contracts on Ethereum, reading smart contracts is a fundamental and important operation. Here is an overview of the process for reading the ENS smart contract. The first is to perform the hashing names process for a queried Ethereum domain name in the ENS. In Ethereum, the Ethereum name system uses a concept called hashed names to identify any given domain name. This hashed name is a special identifier consisting of two parts. The first part is a string representing the top-level domain, such as .eth. The second part is a 32-byte hexadecimal hash value representing the subdomain of that domain name. To perform this step, the Ethereum domain name being queried needs to undergo hashed name processing, which can be done using a hash function to convert the queried domain name into a unique 32-byte hexadecimal hash value. The second is get the address of the ENS smart contract. To use ENS, you need to obtain the address information of the target smart contract on the Ethereum network. This can be done by using tools such as blockchain explorers or dApps to search for the address of the smart contract. The third is register API for smart contracts. To facilitate interaction with external applications, smart contracts need to define an interface. On Ethereum, smart contracts use the application binary interface as the specification for this interface. The smart contract API defines the contract's function interfaces, parameter types, return values, and other relevant information. It also specifies the method of invoking the smart contract, and the manner in which parameters are passed. The API of a smart contract is usually stored in JSON format and contains the following information. The function interface of a contract. It includes information such as the function name, parameter list, and return values. Function parameter types, which include types like unite, 256, bool, string, and so on. Encoding method of functions input and output parameters. The smart contract uses encoding formats such as Solidity API. Smart contracts use these encoding formats to encode the input and output parameters of functions in order to interact with Ethereum network. In the Ethereum network, it is necessary to use the corresponding API file to define the contract interface in order to achieve proper parameter passing and result passing. Register the API typically refers to loading the API file into the local application for easier invocation of contract methods. Ethereum development tools such as Remix IDE and Truffle provide API editing and generation tools, allowing developers to easily create and use the API of smart contracts. When calling a contract function, you need to provide the function name and function parameters and pass the encoded bytecode of the function parameters according to the API encoding format. Ethereum nodes will package this information into a transaction and send it to the Ethereum network for execution. In the last step, the data of the smart contract can be read. By calling the corresponding function interface through the smart contract object, we can read the data in the smart contract. Of course, this requires ensuring that we have a smooth connection to the Ethereum network and sufficient access permissions. In the next lesson, we will write code to demonstrate how to read smart contracts. See you in the next lesson.